Hello everyone, and welcome to this video in which we are going to look at the use of timer functions in programming Arduino microcontroller. The first timer function that I want us to have a look at is the delay milliseconds function. So the syntax for using this function is delay into brackets. We specify the time duration or the amount of time in milliseconds that we want to delay the program with. Remember that 1000 milliseconds make up 1 second. So for example, if we say delay into brackets 1000, then in this particular case, we are delaying the program with a time duration or amount of time equivalent to 1 second, because 1 second is equivalent to 1000 milliseconds. So this particular function returns nothing. It returns nothing, but of course the amount of time is specified as unsigned long data type. So it is unsigned long data type. Let us take a look at an example program in which we are using the delay millisecond function. Basically, in this program, we want to toggle an output pin between on and off with a time duration or time separation of 1 second in between. That is 1000 milliseconds. So in our program, we're going to first of all declare an integer variable, which we are going to call LED pin, then assign it digital output pin number 13. So we're assuming that our LED is connected to digital output pin number 13. Then under the void setup function, we're going to use that as an output pin. So we use the pin mode function, LED pin, which we have declared up there. We set the pin mode to be output. So we're using that digital pin as an output pin. In our earlier videos, we had already looked at the pin mode function. And at the void loop function section, we use the digital write function to that LED pin. Remember, the same way in which we had declared it up there. We send that pin or we set that pin high. So basically, when we send a high output to that pin, we are turning on the LED. Then we put a delay of 1 second, that is 1000 milliseconds. And then thereafter, use again the digital write function to that same pin, the LED pin number 13. We now turn it off by sending a low signal to that pin. And then again, we put another delay of 1 second, that is 1000 milliseconds. So basically, this is a simple program illustrating how we can use the delay milliseconds function, in which case we are toggling an output LED pin number 13 between off and on with the delay separation of 1 second or 1000 milliseconds. So if I pick this particular code and I take it to Arduino IDE environment. So let me share my Arduino IDE environment. So if I take it to Arduino IDE environment, put that code there. So this is how the code will look like in the Arduino IDE environment. Then we can verify. And as we can see, the code is free of errors. Now that is that for the delay millis function. But we have another timer function in the name of delayMicrosecnds function. The delayMicrosecnds function does the same thing as the millis function, only that now it gives us a much smaller or a much shorter time delay. Of course, we know that 1 million microseconds is equivalent to one second, or in other words, 1 second is equivalent to 1 million, is equivalent to 1 million microseconds. 1 second is equivalent to 1 million microseconds. 1 second is equivalent to 1 million microseconds. So instead of us using the long delay time in terms of the millis function, we can deploy the delay microseconds function to help us or enable us realize a much shorter delay time. So this is the syntax for using the delay microseconds function. So you say delay, take note M here is capital, delay microseconds, then into brackets here, you specify the amount of time duration that we wanna pause the program in microseconds. So the supported data type here is the unsigned integer data type. And of course, it returns nothing, just as it was the case with the delay millis function. So in this particular example program, we basically configuring digital output pin number 8 as an output pin. And then thereafter, we are sending a train of pulses to that digital output pin number 8 in time durations or periods of approximately 100 microseconds. And take note that this time duration of 100 microseconds is an approximated time to also include the time duration required to execute other lines in the code. So looking at the program, then we can see we have an integer variable output pin. We've assigned it digital output pin number 8. Then under the void setup part, we are using the pin mode function to set that pin number 8 as output pin. So that digital pin number 8, we want to use it as output pin. So under the void loop section, we're using the digital write function to turn on that pin. So we are sending a high signal to the digital pin number 8. So we're turning on the pin. Then we're putting a delay. So this one is delay microseconds, and therefore now we are pausing the program for 50 microseconds. Then again, we use the digital write function to that output pin number 8. We turn it off by sending a low signal to it. And then again, we put another delay of 50 microseconds using delay microseconds function. So again, if we pick this program and then take it to our Arduino IDE and compile, so we can pick the program, take it to our Arduino IDE and compile or verify. And again, we see it is free from errors. Again, we see it is free from errors. The next category of timer functions is the millis function. There are two functions that we can use to check on for how long the microcontroller has been running since the last time it was turned on or the last time it started processing a program. So the millis function is one of the timer functions which does this. And in this case, it is going to use a hardware timer in the Arduino microcontroller. The Arduino microcontroller board has got 3 inbuilt hardware timers. Of course, these timers can be operated without any interference on the program that is currently running, because the timing operations executed by the hardware timers are independent of the flow of execution of the program. So the millis function is one of such kind of a function that uses one of the hardware timers within the Arduino microcontroller to be able to tell us how long the microcontroller has been running since the last time it was turned on, or it started executing a program, or since the last time it was reset. So anytime a programmer calls the millis function, it will basically tell the programmer how long the program or the microcontroller has been running. So because the millis function uses unsigned long data type, it will take about 50 days to reset to 0 or to overflow. It will take about 50 days to reset to 0 or to overflow. And of course, as I mentioned earlier on, this one being the millis function, being that it is using one of the hardware timers, it has got no impact on the flow of our program or other resources within the original program. So the syntax of using the millis function is specified here. So the parameters, we don't specify any parameters inside the function there. But what it returns when the function is executed is the time duration over which the microcontroller has been running in milliseconds. An example of a program that is illustrating how we can use or deploy the millis function is given here, where basically this code, we're using it to print on the serial port the total time duration in milliseconds passed from the last time the microcontroller started running, or since it was turned on. So we have the first line of the program here is unsigned long time. That is the kind of data that this function should return, unsigned long time. So as you can see here, we have declared a variable there, time, and it is unsigned long data type. So under void setup, we can set the serial communication speed using the serial.begin function. So you say serial.begin, into brackets you put 9600. Under the void loop part, we can print onto the serial port. So we say serial.print, then time, space. So it will print time with full colons. Then what should be put here? What should be put here? We get it from the next two lines. This function we had declared up here, or that variable we had declared up there, sorry, called time, we assign it the millis function. So that whatever the millis function returns should be assigned to the variable time. And then we print it using now serial.print on a new line, time. The same way it was defined here is the same way we use it there, and it's the same way we use it there. So we're going to print the time since the program started running. And then we can put a delay of 1 second, that is 1000 milliseconds. So in this case, again, I can pick the code. So if I pick the code, then I take it to Arduino IDE. Pick the code, take it to Arduino IDE, then compile. As you can see, the code is free from errors. We come back. There are some situations where we may want to check for how long the Arduino microcontroller has been running, yes, but using a smaller unit of time. So instead of us using the millis function, which of course takes 50 days to reset, then we can use the micros function. So the micros function, in this case, it will reset far much earlier. Like every 70 minutes, it will be resetting to 0 or overflowing after every 70 minutes. So the syntax for using the micros function, micros, then we don't specify any parameters in the bracket there. And what it returns to us will now be unsigned long data type. So it will be the number of microseconds taken since the microcontroller started executing the program. Since the microcontroller started executing the program. So basically, when using the micros function, in the original program here, if we wanted to use the micros function, then we will just come here now and then replace the millis with the micros. Replace the millis with micros. Okay, and basically now the other sections or areas of the code remain the same. So thank you for listening to me and for being patient with me. In this video, we have looked at timer functions, 4 of them. The first timer function we've looked at is the delay function, which is used to specify the amount of time that the program needs to be paused in milliseconds. Then the delayMicrosecnds function, the time duration over which the program needs to be paused in microseconds. Then we've looked at 2 functions that we can use to check on for how long the microcontroller has been running. The millis function returns to us or specifies to us how long the microcontroller has been running from the last time it was turned on in milliseconds. And then the last timer function, the micros function, returns to us the total operating time or running time of the microcontroller, but in microseconds. We've seen that the millis function will take up to 50 days to overflow, whereas the micros function will take up to 70 minutes to overflow. That's about 1 hour, 10 minutes. Thank you for listening to me. In case you're watching this channel for the very first time, you can take a second and hit the subscribe button. You can also like our videos. For those who have subscribed, thank you for your continued support. Bye-bye for now. See you next time.